recording here. So this is the classification of organic compounds. So classification will just help you, place things around. So when we study, we study it in these different types of groups. Like a particular type of organic compounds all will have like a similar kind of reaction that is taking place here. So classification, that's where it will help. So if you have organic compounds, all the organic compounds, so you can classify them into aliphatic compounds, or aromatic cyclic compounds. Here. So aliphatic are basically your, you can also call them acyclic, like the compounds that are not cyclic, cyclic or acyclic. Okay. So aliphatic is basically, they are not cyclic compounds. Not cyclic matlab, they are basically open chain compounds. They're pretty straightforward. They don't have any closed structure in their molecules, no rings at all. Okay. And then cyclic, obviously they contain a ring structure. So ring structure matlab, any closed shape is a ring structure. So you have a 6-membered ring here, you have a 5-membered ring here. It can have multiple bonds also.
Ma'am, when we say open chain, does it mean like the normal one when CH3, CH2, only that one is called open chain, right?
Yes. So that's what, as long as you don't have these kind of structures, it's all open chain, like straight chain structure. Like it can be straight or branch chain, but yeah, open, no closed structures. We had also discussed like different representations of organic compounds. So do these random scribbles and lines make sense?
Yeah.
Yeah, like every intersection, there's a carbon.
Correct.
And then after that, we have to fill in with the H.
Yes. So all the, like if you think, oh, carbon only has 2 bonds here, baki do valency kidhar ke, they're connected to hydrogens by default. Yeah. So these kind of compounds, they can have functional groups like other branches and things, but yeah, as long as they don't have a ring structure, it's a cyclic it's not necessary that they only have ring structure. This kind of a compound also is a cyclic compound. Yeah, if there is even a single ring structure, baki jab jo bhi hoga, like it will come under cyclic. Now within cyclic, you have 2 different types. Okay, so one is called alicyclic, and the other is called aromatic. Yeah. So alicyclic is if they have a ring structure without resonance. So the only differing factor between alicyclic aromatic is that aromatic compounds usually have resonance in the ring structure. So alicyclic are just pretty straightforward, no resonance. So these 3 examples that I've given here, they're all alicyclic. So this is cyclohexane. This is cyclopentane. It can have a random double bond also, cycloheptene. Yeah. As long as there's like a closed structure and no resonance, it's alicyclic. If there is resonance, the main, like the root of all aromatic compounds is benzene. We have alternating double and single bonds. So Aromatic compounds are called because one characteristic property is that they have a typical aroma. You know, they have some sort of a smell. It doesn't have to be like really nice smell, but they always have some sort of a smell. Aliphatic, alicyclic, some compounds have smell, others don't. Like it's very iffy. But aromatic compounds all have a specific smell. One aromatic compound all of you guys are familiar with. I'll draw the structure here.
Ma'am, I had a doubt.
Wait, do you recognize the structure? No? So this is the structure of naphthalene. So you have alternating single double bonds. So this naphthalene is aromatic. And then you must know the aroma of naphthalene. It has a typical smell. So even like perfumes and things, artificial sweet smelling thing, esters, if you remember from 10 standard reactions. So esters are sweet smelling. Okay, esters don't typically have resonance going on. But yeah, a lot of like aromatic compounds, like things like camphor, a lot of organic compounds, they have some, this kind of a structure going on, which gives them a characteristic smell. Yeah. Yeah, Rishad, you said you have some doubt?
So ma'am, I have two doubts. So for alicyclic and aromatic, in alicyclic, are there only single bonds? That is why it's not resonance, or do they also have double bonds?
They do have double bond. That's why I gave this example also, right? Like cycloheptene is one. The thing is, we will talk about resonance in a later section for sure. It is one of the electrons wala thing, right? Resonance, we already touched upon it, that the pi electrons keep shifting here and there. So there is a specific condition to figure out if an organic compound will have resonance or not. So like it's basically, roughly speaking, if it has alternating single and double bonds or alternating single bonds and lone pair of electrons, the, what do you call it? The probability that it is resonating is high. Like uske saath kuch aur hai, like 2n plus 1 pi bonds hona chahiye, like all that stuff. So that we will do it in detail later on. But yes, so alternating single double bonds is one thing to look out for in resonance. So double bonds ho sakte hai, but if it's not like alternating, like let's say you have something like this, double bonds hai, lekin this is not resonating. इसमें resonance नहीं होगा, this is not aromatic. Yeah. Within aromatic compounds, there's three more different types. कहाँ पे लिखूं? Like if you guys have space, you can write it below aromatic itself. I'll just take it to the next page. So अगर aromatic है, so depending on what you have in the structure, it is further classified into three types. So one is benzenoid. So if the resonance is coming from a benzene-like structure, so benzene is basically 6-membered ring with alternating single and double bonds. Okay, so benzene itself is benzenoid. Benzene derivatives hai, like benzene se nikala hua compounds, things like phenol or chlorobenzene, benzoic acid. These are all aromatic compounds with their aromaticness coming from a benzene ring. Okay, so there you have benzenoid or non-benzenoid. Yeah.
What are the examples for benzenoid?
So benzene itself, and then you have phenol, then you have chlorobenzene. Even naphthalene, it's 2 benzene rings.
I was gonna ask that.
Yeah. Okay, so wherever you can find like a recognizable benzene ring, that's benzenoid. Then you have non-benzenoid. And then the third one, let me just shift this, is heterocyclic. So heterocyclic, again, you have the word hetero. So if there is a non-carbon present, like a non-carbon atom present in the ring. So अभी तक जो भी examples देखे हमने, ring is made up of all carbon atoms only, right? So if there is a non-carbon atom present in the ring, like for example, there is this kind of a structure. So it's a 5-membered ring, but it has like 4 carbon atoms and one of them is an oxygen. The fifth is an oxygen. Okay, so pyridine is another, so that has nitrogen here. And I'm not sure, like there is, so I'll just get some examples of this. Furan is one.
Ma'am, so non-carbon, if there is anything that is non-carbon, we'll get it as heterocyclic.
Yeah. Anything matlab, it should be present within the ring. Like for example, so this one's name is furan.
Is ribose an example?
Ribose, I need to look at the structure for ribose. Ribose is not, it is not aromatic. So it's not a heterocyclic aromatic compound, it's an alicyclic, like heterocyclic, but alicyclic. Okay. So furan is one, thiophene is another. So thiophene is similar to furan except with sulfur. Yeah, Kaveri?
Sorry, by mistake.
Ma'am, so now for example, we take phenol and instead the OHB and another branch, if it is with the ring, then it would be heterocyclic.
Yes. Pyridine is another example. I got the structure of pyridine. So 6-membered, where one of them is nitrogen, and this is the structure. This is thiophene. This is pyridine. Pyridine is like it's used as a reagent in a lot of chemical organic reactions. It's a very extremely basic this thing.
Ma'am,
Hmm?
does pyridine have resonance?
Yeah.
Oh yeah, wait, they have alternating bonds, yeah.
Then what is non-benzenoid?
Non-benzenoid, I'm just trying. So there's tropone, which is a 7-membered ring. And it looks like this. And there's azulene. So it is 7-membered and a 5-membered. So this is tropone, this azulene. These are just examples. So these are just like, because we're discussing classification, these are some of the things. When we, like in the syllabus, we'll be dealing only with like benzenoid compounds and all of these aliphatic compounds. So some alicyclic may come into picture, like, specific reactions, but mainly aliphatic, and within aromatic, only benzenoid compounds. You won't be dealing with non-benzenoid heterocyclic a lot. You'll come across these names, like pyridine, as I mentioned, is a basic compound. You use that as, if you need like a basic, medium to do any organic reaction, then pyridine is like one of the bases that is used. So,
Ma'am,
yeah.
You go ahead.
okay. So like if there's the compound which is like an like a combination of benzene and an aliphatic compound, so will it still come under aromatic?
Yeah, absolutely. As long as there's resonance present, aromatic one, yeah. Like presence of aromatic ring is like, even though you add aliphatic nature to it, it won't remove that resonance from that structure, right? Like as long as it's present, yeah, it's aromatic. So yeah, toluene is also an aromatic compound. So toluene is another derivative of benzene, where there's a benzene and then you have a methyl group attached.
Ma'am, so my doubt was like I did not understand what were non-benzenoid.
So if you don't have a benzene ring, so benzene ring is a 6-membered aromatic ring. तो अगर benzene ring नहीं है, फिर भी aromatic है, so then that's a non-benzenoid aromatic compound. The non-benzenoid, oid is like you attach oid to mean like something, right? Like humanoid robot is a robot that's like a human. So benzenoid is something similar to benzene that has a benzene ring. Non-benzenoid is something that's not benzene-like. So tropone doesn't have any benzene structure, like any structure similar to benzene. It's a 7-membered ring. Azulene also does not have any structure similar to benzene. 7-membered ring plus 5-membered ring. So these come under non-benzene.
Okay.
In fact, these things are also like at least furan, thiophene can also be put under non-benzenoid, but they are also heterocyclic. Kyunki ring mein you have like this oxygen and sulfur, atoms that are not carbon there, so heterocyclic.
Also, ma'am, like when we're writing benzenoid compounds, instead of putting those 3 lines inside, we can just put a circle also, right?
Oh yeah, absolutely. Now because I didn't discuss resonance with you guys, I didn't do the circle, but going forward after this particular chapter, every time I write benzene, I'm going to put a circle by default unless we're doing the mechanism. So when we're doing the mechanism, so we need to show that bond, but otherwise I'll be using the circle only. Okay, so these are the different types of compounds. It's easy to figure out because generally properties of a specific type are very similar to each other. So like if I take an acyclic, like open chain, like something like this, chloroethane, and keep it in sulfuric acid, I'll get a completely different reaction if I take benzene and keep it in sulfuric acid. So that is why understanding the difference between this, like knowing that, okay, different types of compounds here and this is where they differ is important. Because
Ma'am, what if it's chlorobenzene? Will that make any difference?
no, again, chlorobenzene, because of the resonance that aromatic compounds have, that gets into the fray, like that starts deciding, okay, किस तरह का reactions हो सकता है, like how will this behave in the presence of sulfuric acid or in the presence of acetic acid or anything like that. So benzene and chlorobenzene will behave similarly, and that they'll have minor differences, but like overall it's going to be the same. It's going to be very different from chloroethane, like acyclic compounds. So when we study the properties also, we study it like separately. Alkyl halides किस तरह के reactions undergo करते हैं, then aryl halides किस तरह के reactions undergo करते हैं, that. That's why this classification is important, in the sense that you need to be familiar कि अच्छा इस तरह के compounds होते हैं, they're very different from इस तरह के compounds. So just be familiar with this. ठीक है, noted.
Ma'am, I'm still confused between the difference between benzenoid and non-benzenoid.
Simple. Benzenoid, non-benzenoid. So if it contains benzene ring, then it's benzenoid. So naphthalene में you can see there are 2 hexagonal rings. 2 benzene ring है इसमें. Phenol में there is a benzene ring. Chlorobenzene में there is a benzene ring. Toluene में there's like a benzene ring. So these are all benzenoid. Non-benzenoid matlab they are aromatic without the presence of a benzenoid structure. So tropone में do you find any benzene ring?
Yeah,
Either.
like there are alternate double bonds, right?
Resonance के लिए that's a criteria, like whichever resonating compound you take, it's going to have alternate single double bonds. But benzene का speciality है, it's a 6-membered ring. You need to look for the hexagon structure. तो यहाँ पे hexagon है क्या?
No, it's 7.
Yeah, 7-sided, non-benzenoid. Similarly, azulene में
It's 6 only.
1, 2,
Oh, sorry, 7.
4, हाँ 5, 6, 7. 7 plus 5 है. तो benzene ring कहीं नहीं दिख रहा है. So that's why this is non-benzene. That's the difference.
Ma'am,
Hmm?
so like in aromatic, it needs to be resonating, right?
Yeah, resonance structure is present. So aromatic होने के लिए you need to have a closed ring structure, and उस ring structure में there needs to be resonance present. Any sort of resonance, yeah.
But like, are non-benzenoid also resonating?
Yeah, these specific non-benzenoid are resonating.
Because like they don't have alternating, right?
Double, single, double, single, double.
Oh wait, we count that also.
Yeah, even in fact, like it gets deeper, Sanat. So even in phenol, the presence of oxygen, like oxygen has lone pair of electrons, chlorine has lone pairs of electrons. So these also get into the resonance, and this like resonance is a whole subtopic in this chapter. So we're going to go through that.
But ma'am, that double bond in tropone is like outside, right?
Could be like the main thing about resonance is the possibility of electrons being delocalized. तो अगर यहाँ पे एक pi bond है, यहाँ पे एक pi bond है, so these two carbons are anyway forming pi bond. Instead of forming on opposite sides, they're perfectly capable of forming a pi bond with each other also. So that's kind of like what happens in resonance.
And ma'am, what about the lower one, azulene?
Azulene also, like these double bonds will keep shifting. Like electrons moving is resonance. So as I mentioned, like resonance is a whole subtopic. We will go deeper into it. We will look at, exactly what is the movement of electrons that are taking place. But before that, there's quite a bit that you need to get familiar with. Like you need to get familiar with carbocations and carbanions and all of that stuff. So we will get there eventually. Okay.
Okay.
Ma'am, for benzoid, so a benzenoid, so for that, it is not necessary for it to be resonance, or it is compulsory that it is also resonance.
All of them are coming under aromatic. And the whole thing about aromatic is there needs to be resonance.
So for resonance to take place, even two double bonds are also okay, right? That is alternately that.
Two double bonds. See, there's certain criteria for resonance, Rishit. As I said, resonance is a whole subtopic, so we'll get deeper into that. So, why resonance takes place, whether this thing has resonance or not, hold off on that. For now, just understand that, like, just get familiar with these particular terms. Okay, as long as you're familiar about difference between aliphatic, aromatic. Aliphatic matlab straight open chain. Difference between alicyclic, aromatic. This is pretty straightforward. Isme resonance hona chahiye. Yes resonance, aromatic. No resonance, alicyclic. Okay. And under aromatic, all of these are aromatic, but because of minor differences, like benzene based compounds itself is like a whole truckload of compounds. Okay, so that's why we study them, like we just like isolated them, at least for the sake of studying separately from non-benzenoid, and then again differently from heterocyclic. This is just classification for you to be familiar with. Okay, classification is based on these specific properties. One, structure kaisa hai. Two, is there resonance in the structure or not? And three, are there any other minor differences we can pick within the structure? Like resonance is with atoms that are not carbon. Like in this case, resonance is completely with atoms that are between the carbon atoms within the ring. Things like that. Okay. For now, like, are you guys familiar with the classification? Like, do you understand the basis for the classification? Like the difference between benzenoid versus non-benzenoid versus heterocyclic. Rather than that, focus mainly on aliphatic versus allocyclic versus aromatic, because in तीनों में ही major differences in properties होते हैं. So clear with that?
Alicyclic में the fourth structure that you do in alicyclic. Why is that not aromatic?
It's not aromatic because again alternating single double bond nahi hai. And you can see, so another thing about aromatic is if every single compound has sp2 hybridization, that's more favorable for aromatic. इसमें these two are sp3, ये तो tetrahedral structure में बैठे हैं. These three are in the same plane, so that's another factor for its non-aromaticness. See, why aromatic, whether something is aromatic or not, we will get to that later, because resonance is a whole topic on its own. For now, if you know that something is aromatic or non-aromatic, can you classify them within alicyclic, aromatic, aliphatic? Like, can you do that much is what you need to look at.
Yes.
Yeah. Cool. Like any questions about how aromatic, like, where does the aromatic, like how is it resonating or not, is going to come in the future, because that's a whole subtopic on its own. Uske liye you need to be very, very clear with the structure and all of that stuff. Yeah. Okay. So are you guys clear about the definition of these types? Like, can you identify if I give you a compound key, whether it's aliphatic or at least alicyclic aromatic, like at the minimum between these three?
Yes, ma'am.
Yeah.
Okay.
Yep.
That's it.
And what was toluene?
Sorry. Toluene is this. So benzene ring
Benzene
है,
plus CH3.
membered carbon plus a methyl attached to it.
Will it be 1-methyl toluene or something like that?
No. IUPAC, like the next thing is nomenclature. Don't just jump, guys. We'll go step by step. नहीं तो बहुत ही confusing हो जाएगा.
Ma'am,
Yeah?
methyl is also cyclic.
No. So this specific thing is called methyl. Like that's what we're going to discuss abhi. What are, how do you call organic compounds? What are their names? What are their parts?
No, but I remember like last year, it was something like alkane and alkyne was there, and then there was alkyl, which was the cyclic form. So I was asking,
It
is
is not
methyl?
cyclic. No. That's completely wrong. So
And what is that?
cyclic. So we'll Kaveri one step at a time. No, we haven't done this chapter yet. Okay. So nomenclature, what are like the rough rules you guys remember about nomenclature? How much do you guys remember or know of nomenclature? Like how do you name organic compounds? IUPAC system say.
Depending on the number of carbons, meth, eighth, prop, but, all that.
Okay.
And if there's a like double bond or a triple bond, depending on what position it's on, like if it's on the second carbon on a propane, so it would be prop to ene, like that.
Yes. Awesome. Okay.
And if there is also a functional group, that will be mostly given priority in terms of numbering.
Very good. Correct. Yes. Nice. You guys remember all the major points. Very good. So nomenclature may, as Kaveri said, you need to count the number of carbon atoms. So that will decide something called so that you call that particular chain the parent chain, and that will decide the root word for it. Naam, like the root word of the name. Okay. So step 1, always you need to choose the longest chain. Okay, so this particular chain is called the parent chain. Okay. Then the number of carbon atoms in this chain, in the parent chain, will give you the what do you call, like the main parent name. You can also call it like the root word. Okay. Another thing you need to take care of is when you're choosing the longest chain, the highest priority, like the main functional group, so the highest priority functional group should be present in the parent chain. Okay. So even if, like for example, if I have a structure like this, and I put a COH over here and another CH3 over here. So even though, like if I choose, for example, oh God, I didn't mean to do that. Yeah, if I choose this particular chain, there are 5 carbon atoms, but you're not including the COOH over here. So even though that is still the longest chain, because the functional group is not excluded, that will be wrong. So you need to choose the longest chain that contains the functional group. So COOH is your functional group. Choose the longest chain containing COOH. So if I go 1, 2, 3, 4, I get 4 carbons. 1, 2, 3, 4, still 4. 1, 2, 3, 4, still 4. Like, okay, wherever I go, I'm getting 4 carbon atom chain. So that's what I'll have to do. Yeah, and let's say I just choose this then. Okay. So you need to choose the longest chain, yes, but the functional group should be present in the chain that you're choosing. Like whatever chains have the functional group, usme se it should be the longest. So that'll give you the root word. So abhi, okay, you've decided, you figured ki there are 4 carbon atoms here. So 4 carbon atom chain hua, so what will be the parent name? The root word kya hoga? Do you guys remember? 4 carbon atoms ke liye?
Prop.
Beauty.
Sorry, bute.
हाँ, bute. And functional group COH का नाम याद है?
Acetic acid.
Acetic is specifically for CH3COOH. अगर 2 carbon atom है, तो that is acetic acid. So acetic acid is not for like all the acid compounds. Kaveri, yes, it's a carboxylic acid, yes. But nomenclature mein, do you remember? Do you have, like by chance, do you remember the name? No problem if not. I'm just checking. Okay. So, agar acidic group hai, so you end it with oic acid, butanoic acid. So this is my parent chain. Abhi, then parent chain ke alawa, what else have we left alone in this structure? So we left alone this methyl and these two, this ethyl group here. So then those substituents will be added on as a prefix. Okay. So the whole funda behind nomenclature is so structure say you need to deduce the name, and then if you're given the name, from the name also you should be able to deduce the structure. So that like that way, this particular logic that is there, these rules that are there, it is so exact that just by looking at the name, you should be able to figure out ki acha iska structure kya hoga. Like for example, oic acid hai, I know that there is a COH present group that is present. फिर butanoic acid hai, matlab I'm going to start off with acha, there are 4 carbons and usme se ek hai COH. Then depending on the prefixes, then I can, figure out ki aur kya hai structure. Okay. So from the name, you should be able to get the structure, and structure say you'll write the name. Like it is very exact. And the second funda, like the whole reason behind nomenclature is it's a standardized way to write the name that you don't have to like remember the name of different compounds. Just by looking at the structure, you can like figure out the name based on the logic, and every single organic compound will then get a unique name. So agar do structure ke naam ek hi aa raha hai, it means that either you're making some mistake in like the process of naming it, or those two structure happen to be the same thing. Aisa bhi ho sakta hai na? Like if I write, if there is a structure like this, and if there's another structure, I'm writing it like this. Now, both of these are the same structures. Like these molecules are 3D. So if I just like flip this 180 degrees, I'm going to get this structure only, right? So that you can figure out, like both of these, because they are the same molecule, I'm going to end up with the same IUPAC name. Yeah.
Would this be isomeric structures?
These are not
Because-
even isomers. So isomeric structures may you get completely different names because they are completely different structures. If you have a specific structure, agar naam same hai, matlab they are the same compound. So this is also 2-chlorobutane. This is also 2-chlorobutane. Clear? So that way. Rules. Yeah.
That butanoic thing, उसके पहले क्या होगा फिर?
We'll figure it out. Okay. So the next rule, like once you've figured out the parent chain and the functional group, the main functional group will always get the lowest position number. So यहाँ पे you have multiple branches, right? So the way you indicate कि इस carbon atom को attached है methyl group, ये वाला carbon atom को attached है ethyl group, the way you communicate that is with position numbers. So oic acid, this functional group is such that it will always take the ending wala place. So this will always get like position 1. So you may, like a lot of places ignore it. Like you don't even have to write 1 butanoic acid because it is accepted that butanoic acid hai, matlab uska position is always 1. Then start counting from here. Agar butanoic acid ye wala carbon is the first carbon, then always go in a continuous way. So first carbon, then bond. This will be the second carbon, where this will be the third carbon, and will be the fourth carbon. So second carbon pe, there is this particular group. 2 carbon atom wala group hai. So this is ethyl. So it's 2 ethyl. And third carbon atom ko bonded hai this CH3. So this is methyl. So it's 3 methyl.
How did you figure out that it is ethyl methyl?
Yeah. This is 3 methyl. So this is how you write the substituents. Okay. So that's like roughly the rules. I'll give you guys the rules in detail. Before that, we'll discuss the names for functional groups, name for the branches and chains, so that there is no confusion here. Okay. The first thing is based on the number of carbon atoms.
Ma'am, could you go back to the previous slide?
Now ignore it. Like note down the names first, and then we'll come back to the rules.
No, like the butanoic thing that I don't need to note down.
No, we'll do more practice with this. So,
Okay.
So based on the number of carbon atoms, this you absolutely have to remember it. So I'll just give it for first 10. Won't get more than 10. So, you guys are able to see 1 se leke 10 tak visible?
Yes, ma'am.
Okay. So agar 1 hai, so I'll start with meth, eth, 3 is prop, 4 is but. Only these 4 are weird. 5 se leke, it's very intuitive. So what will be for 5 carbon atoms?
Pent,
Yes.
Pent,
then hex,
Yes.
hex,
then sept.
hept,
Hept. Small difference. S will become H. Hept. Okay. 8,
oct,
9.
Something NO something.
non,
Yes. Non-ane, non. And 10,
deca,
dec. इसके बाद will depend on, okay, like is 10 carbon atoms के साथ क्या कर रहे हो? If it's just single bonds, then decane. अगर OH घुसा रहे हो तो decanol. There's a double bond and there's decene. इसके बाद it'll change. Okay, so these are all based on the number of carbon atoms. Then, so based on what bonds are there within the thing, mainly applicable for aliphatic. क्योंकि अगर aromatic है तो you're going to get benzene related names there. Yeah. So if it's a single bond, ends with ane, if there is a double bond, ends with -ine, and if there's a triple bond, ends with -ine. So these are prefixes. So you can just put a hyphen after this. So अगर 4 कार्बन एटम्स है जिसमें एक ट्रिपल बॉन्ड है, तो इट इज ब्यूटाइन, BUTYN.
Why you've written aliphatic?
Because you will use these suffixes when there's like or instead of aliphatic, let's call it non-aromatic. क्योंकि benzene में double bonds है, but you're not gonna call it hextriene or something. Benzene is its own thing. Like उसका IUPAC name itself is benzene. So non-aromatic. If it's not aromatic, then you're going to use these prefixes. If it's aromatic, you're going to use its actual name like benzene or xylene.
Ma'am.
Yeah.
So like this year, will we be having questions on non-benzenoid and heterocyclic?
No. We'll focus mainly on benzenoid. Like be it properties, reactions, naming, जो भी है, benzene-based compounds.
Okay.
Now we look at some functional groups. So functional groups के लिए end में you just have to replace E. So alkane है, so you replace only this E and then add this suffix. So we'll do it like stepwise thing. The first one is if you have a halogen. So halogens, you have like fluorine, chlorine, bromine, iodine. Then the prefix is halo, like chloromethane, या फिर bromopentane, 5-bromopentane, 3-chloro-7-bromohexane. Just randomly saying. Okay. So when you have halogens are usually represented by X. So X can mean F, Cl, Br, or I. So depending on which halogen atom you have, you just say halo that compound. Like iodobutane, for example. If you have a 4-carbon atom, जिसमें से एक iodine attached है, so it's iodobutane that way.
Don't we have to write where the iodine is attached, like to?
Yeah. No, now I'm just getting you guys familiar with the names, prefixes, suffixes. So positioning and all, when we're constructing the whole name, तभी देखेंगे. Okay. So don't say halobutane. I'm saying be specific, like iodo, use chloro, like that. Then we look at some oxygen-based functional groups. So if it is, if this particular group COOH, जिसका structure है C double bond O OH. So this is a carboxylic acid, ends with oic acid. So the way you read this is replace only the E. तो अगर compound में double bond भी है और carboxylic acid भी है, then it becomes like something like pent-ene-oic acid. So 5 carbon atoms है तो it is pent. एक double bond भी है उसका उस structure में ene. Then instead of the E, COH भी है pentenoic acid. So that's how you construct the names. Okay.
Ma'am, in halo, what's after chlorine?
Bromine, Br. Halo nahi, halo, like halogen.
Yeah, I tend to call it halogen sometime.
Oh, okay.
Yeah.
Ma'am,
Mhm.
could it also be like iodide, or those won't be there, right? It could be
Yeah,
for how do you?
yeah, you call it like methyl iodide and all that, but they are not IUPAC names. That's like normal colloquially baat karte karte people use it. IUPAC के लिए specifically it'll come in front of the name as iodopentane or iodonone, that way. So these are specifically for like IUPAC names. Common names, obviously, depending on the history and how people use it, thoda changes obviously, right? Common names के लिए there's no rules. It's like, think of your name, right? Like your formal official name is your first name and last name. A lot of cases, you also find first name and then your father's name and then your last name. But your pet names ke liye, there's no rules. Like it can be derived from your own name or like random Chotu, Chintu, Bantu, jo bhi hai. So IUPAC name is the formal name that follows these rules. So this is oic acid. And then you have your ketone and aldehyde. So if it is C double bond O and then H, which is your end of the chain thing, then this is also written as, let's just follow the format. I'll write the thing and then the CHO structure is C double bond O H. So this is called aldehyde, ends with Al.
Ma'am, but I just had a doubt. I still didn't get it. How do you call halogens or some like halogens, iodo, or like how do you like form that name?
From their own names. What is the name of the element F?
Fluorine.
Fluorine, na? So instead of INE, take away INE, put O. So fluoro. I is what? Iodine. So take away INE and put O, iodo. Okay, that's how you get it.
So we only need to add O.
Yeah.
What is aldehyde and what is ketone?
This is aldehyde. Ketone is exactly like aldehyde, but instead of being present at the end and having hydrogen, if there's yet another carbon atom here, then it becomes a ketone. So then it ends with ON. So this is a ketone. So agar C double bond O, if it's present at the end of the chain, uske baad koi carbon atom nahi hai, matlab there's only hydrogen, then it's an aldehyde. If it is present in the middle of the chain, then it is called ketone. So is taraf bhi carbon hai, is taraf bhi carbon hai. Acha, before we go forward, because we're dealing with this, I'll tell you guys. Okay. So you have alkanes, right? What are alkanes?
Single, like
Alkanes are like single bond carbon compounds.
Correct.
Like methane, ethane, propane.
Yes. So alkanes ke liye you just need two things. One is single bonds hone chahiye pura, and the second is they should have only carbon and hydrogen. Yeah. So single bonded hydrocarbons are alkanes. Before we go forward, all this meth, eth, prop, the general term for it is alk. Yeah. Single bond hai, so then you have alkanes. Double bond hai, so it's alkenes. Triple bond hai, so alkynes. Like aldehydes hai, then they will take names of the form alkanol. alkanal. Okay, alk is basically representative of number of carbon atoms. So that can be meth, eth, prop, but, etc. An shows that there's only single bonds in that compound. And this last bit Al shows that it's a aldehyde. So ethanol or octanol.
Ma'am, can you repeat where the AN comes from?
An shows that there's only single bonds. An se aa raha hai.
Okay.
So it can be butanal.
Butanol. Eel is like this.
Yeah, all sorry. Yeah, all.
Al is stands for this aldehyde part. Like it can be, if it is alkene al, it means that there's some obviously carbon compound, meth, eth, pent, hex, jo bhi ho sakta hai. Ene shows that there is a double bond at some place in the compound, and Al shows that it's an aldehyde. Instead of Al, let's say you come across ANONE, shows that there is a ketone group somewhere in the carbon compound. Okay, that's kind of how these names are constructed. Okay, so alk is like a placeholder for the number of carbon atoms. Abhi, within this alkane, if I take away one of the hydrogens, like agar kuch aur, like if I want to attach a halogen or something, I need to take away one of the hydrogens and I can put some other atom or group of atoms in its place, right? So alkanes minus one hydrogen, so they have like one empty bond that is available for some other group, halogen, aldehyde, like whatever it is. So that group is called alkyl. Yeah. So Kaveri, alkyl is not related to it being cyclic and all that. So alkyl is simply an incomplete alkane, you can say. So alkane में से एक hydrogen निकाल दिया हमने. So in that place, you can put anything else. It's like an incomplete compound.
So like saying, because like last year a teacher taught us that in order for it to become cyclic, it loses one of the terminal hydrogens. And what you said is right, like without one hydrogen, but then she said it also becomes cyclic. So I was confused.
That is a completely different thing. Agar cyclic banana hai, to yeah. In fact, two of the carbon atom needs to lose the terminal hydrogens. Tabhi both of them will join in. But that's like a reaction and it's a completely different thing. But yeah, so the incomplete alkane, where you have an empty spot to attach a halogen compound or an OH group or an NH2 group, any other atom here. So that incomplete thing is called alkyl. So alkyls are represented by R. Okay. So R with a empty bond here to show that there's an empty space. We can put something else over here. Okay. So from now onwards, I'll be using R. Like for example, if I have ketone, यहाँ पे एक alkyl group होगा और यहाँ पे दूसरा alkyl group होगा. I've used R dash because it may be same as this or it may be different from this. कोई भी हो सकता है. So if I put R, it means that वहाँ पे alkyl group attached. Yeah. Someone was saying something?
So yeah, ma'am, so for aldehyde, then those IUPAC name will have YL, right? Since it has hydrogen in it.
Why nahi? Al ends with Al. So depending on the number of carbon atoms, you take this. Like let's say it has 6 carbon atoms. Hex. Then if it has all single bonds, then A, N. And then फिर it is ending with CHO, like aldehydic group है उसमें, Al, hexanal. Okay, so that's how you build it.
Yeah, got it. I actually got confused. I thought when we talk about AlKYl, like alkaline, we remove. So I thought we can also add hydrogen and then call it KYL then, but I saw we are minusing an hydrogen and not a carbon.
Yeah. This is like minus. Okay, I think using this is the wrong thing to do. Confusion or that. Just say minus. So alkyls are not compounds, they're incomplete. That's why I've put like R dash over here, like the bond over here, to show that alkyls are incomplete. So alkyls have an empty space to take in an extra atom. So if that extra atom is hydrogen, then it becomes an alkane. If it happens to be chlorine, then it's alkyl halide. But IUPAC mein you call it haloalkane. That kind of like that. So generally, we like, because when we talk about reaction mechanisms, reaction ke beech mein obviously bonds are breaking and new bonds are forming, right? So that moment of time where a bond is broken, there's an incomplete compound. So to refer to that, we say, okay, this methyl group migrates from here to there. That kind of context. Or we can say a methyl group is attached on this side, on one side of the ketone, and ethyl group is attached on the other side of the ketone, like that.
Ma'am,
Huh?
I didn't get why it has to lose one hydrogen in order to attach to another like chain.
Okay, let's say we have methane, CH4N. Will this carbon, can this carbon form another bond?
No.
4 valencies complete हो गया ना? तो अगर मुझे Cl attach करना है, तो what do I have to do? Yeah, so you need to remove one. So at this point of time, like between the thing, when there's one empty space, then it's a methyl group. It has an extra space. So if I'm attaching Cl in this extra space, then it becomes chloromethane. That. Okay, noted these three. Guys, let me know, are you done with these?
Yes, ma'am.
Okay. Sanat, Rishit?
Yeah.
Yep.
Cool. All right. Okay. Couple more with oxygen. Let's say there is a OH group attached. So this is pretty straightforward. So there's oxygen and hydrogen and like carbon chain attached. So this ends with OL. This you should be familiar with. What do you call this group of compounds?
Hydroxide.
Hydroxide is OH minus ion. When it comes like in the context of organic compounds, these are alcohols. Yeah.
It's hydroxyl, right?
So this, if you're referring to this alone independently, that's called a hydroxyl group. The group of compounds where you have a carbon chain and OH attached. Like if you have something like this is an alcohol. You have something like this is an alcohol. If I have like something like this is an alcohol. So like this group of compounds that all have this OH, they are called alcohol. The name of, जैसे R को हम alkyl बोल रहे हैं ना, that way just these OH is called hydroxyl group. Similarly, if there is C double bond O, just this alone is called a carboxyl group. So that's why this is called carboxylic acid. So these three contain a carboxyl group. Yeah, that way, this group of atoms together, say it bond like with an extra bond, this is called hydroxyl group. The compounds that contain this group are called alcohols. And alcohols always end with OL. So aldehydes end with AL, alcohols end with OL.
So ma'am, like this year we won't be using the expanded form of these compounds, right?
Oh, you would. Like this year, there's no whole squad. Like you get all of the, you can get anything. Nomenclature. In fact, whole of, like I'll tell you what all you'll be studying in detail, like preparation, properties, all of it. So this year you only have hydrocarbons. So you'll have alkanes, alkenes, alkynes, and benzene. Specifically only benzene. Grade 12 May, you'll be studying about haloalkanes and haloarenes. Basically, alkanes or benzene compounds that contain a halogen. Then the next chapter is you'll be talking like all the compounds containing alcoholic groups like alcohols, phenols, and then there's another group called ethers. Uske baad you'll all the carboxylic groups, aldehydes, ketones, carboxylic acid. Usi mein acid derivatives hai, you have stuff about esters and acid anhydride and all that. Then uske baad you have amines. Amines are a single like alkyl amines and the aryl amines. These are the functional groups that we'll be studying about in 11th and 12th. Okay, so you have alcohols. Derivative of alcohols, instead of hydrogen, if you have another thing, carbon group, so they are called ethers. So these have like a very adaptable name. So they follow the format of alkoxy, alkane. So you need to look at oxygen के इधर उधर कौन से alkyl groups है. So alkane will be the longer chain and the alkoxy part will be the shorter chain. Okay. So for example, if there is CH3O, CH2, CH3. On either side of oxygen, what are the two groups that you have?
Methyl and ethyl.
Right. So you have methyl and ethyl. Which one is longer?
Ethyl.
Ethyl.
Ethyl is longer. So the name of this compound, this ether, will become methoxy ethane. Okay, so the longer part will be of the form alkane, like methane, and the shorter one will take the oxy suffix, so methoxy.
Ma'am, since
Yeah.
oxygen is attached to CH3, that is why we are calling it as methyl, right?
Only CH3, yeah. That's why it's methyl. Or
Ma'am,
is-
could you explain once more?
See, ether is simple. So ethers are compound, जिसमें the oxygen is bonded to two carbon chains. Like इस तरफ एक carbon chain है, इस तरफ एक carbon chain है. So if you want to name ethers, you need to figure out how many carbon atoms are on either side of them. So whichever has a greater number of carbon atoms, that will take the format of alkane, and whichever has a shorter number of carbon atoms, that will take the format of alkoxy. So I took an example here. Oxygen is here. So on this side, you have only one carbon atom. On this side, you have two carbon atom long chain. So that's why iska naam ho gaya methoxyethane. I'll give another example. I'll keep it simple only so that once you're a little familiar, then we can increase the ओके, अभी इसका नाम क्या होगा? So yeah,
ethoxy
yeah, go ahead.
ethoxypropane.
Absolutely. So यहाँ पे 2 कार्बन एटम लॉन्ग चेन है, यहाँ पे 3 कार्बन एटम लॉन्ग चेन है. So the parent chain is propane, and because this is lesser in number, this becomes ethoxy. Yeah, you got it.
Only for when oxygen is in the middle, right?
Yeah.
Like if there's any other atom in the middle.
So the name will change accordingly. Because there is oxygen, we're calling it ethoxy. Then it's a different, like if this changes, it becomes a completely different functional group altogether. Where
Suppose it was chlorine.
chlorine हो सकता है क्या? You tell me, what is the valency of chlorine?
7, like valence 1.
1. So chlorine can ideally form only one bond. That's why it's always at the end of a chain. That's why uska naam bhi it's like chloro. At the most, agar 2 chlorine atom hai, to dichloro, like it becomes like that.
If it's beryllium, suppose. I don't know, I'm just.
That's what, like we're going case by case, Kaveri. If it's nitrogen, that becomes an amine and it has its own naming system. If it is
Okay.
sulfur, that becomes a different functional group and that will have its own naming system.
Okay.
Okay. So right now we're talking about oxygen related, like whatever you guys have in your syllabus. Oxygen related functional groups, you just have carboxylic acid. Let me write the name. Carboxylic acid, because there is a carboxyl group here. The C double bond O part is called carboxyl group. So carboxylic acid, aldehydes, ketones. So these are all have one common element, that they have a C double bond O group there. Then you have alcohols and ethers. It's single bond oxygen with hydrogen to alcohol. If it's another carbon group, it's an ether. Next, you have nitrogen.
This ROR, that is an ether.
Yeah.
So like, what is the definition of ether?
This is it. Like if you have, it's a carbon compound in which there's 2 alkyl groups bonded to an oxygen atom. You only has definitions and all in this chapter. Lot of better things to talk about. Okay, next we look at some nitrogen related functional groups. Nitrogen again, you have a straightforward if there is NH2. So this particular functional group is called an amine, and the name also ends with amine. Like the name becomes methanamine or propanamine. Name of the group of compound is called amines. They're all called amines, and the IUPAC name also it ends with AMIN. Amine.
Ma'am, can I just come in a minute?
What?
I have to go for a minute. Can I just come back in real quick?
ठीक है. I'm just looking for any
Ma'am,
like a table or something. I can just display it. Yeah, what's up?
can you give an example of amine?
Yeah. So amine, it's pretty straightforward. So if there is CH3NH2, so iska naam hoga, because there's only one carbon atom attached, it's called methane, meth, one carbon, all single bonds AN, NH2 attached, AMIN. This is how you name amines.
What if it's NH instead of NH2?
Yeah, I'll come to that. So there's secondary amines, like tertiary amines and all. I'm just seeing if there's like a table. I'll be pretty convenient. I'll show a table. So this is an example. Like if it's a primary amine, if you have NH2, it's like this. So if it is CH3, CH2, NH2, 2 carbon atoms, so this becomes ethanamine. Now, if you have a secondary amine, so if you have like R, NH, so instead of a hydrogen, if you substitute it with a carbon, this thing, RNH R dash, all of these are called amines, like the class of compounds, they all fall under amines. So these are primary amines. So these become secondary amines. The name is basically like alkyl amine. So, if there's a, like, I'll take an example.
Like methanamine?
So let's say if there's CH3NH C2H5. So ends with amine. So amine, like for this amine group, what all groups are attached to it?
Methyl and ethyl.
Yes. Iska naam will be methylethylamine. It's all one.
Okay, so it's similar to ethers,
Kind of.
like the shorter and longer one.
So ethers, you always mention ethoxy. And because the group has changed, you have NH group here, right? So this becomes amine.
Yeah.
In fact, methyl ethyl is wrong. Like once you've identified it, you need to put it in alphabetical order. It becomes ethyl methylamine. That's it.
For the IUPAC thing.
Yeah. I'll just show a brief thing. So these are all primary amines. So you can see all of them end with NH2. So this is like, informally you just call it methylamine, ethylamine and all, but IUPAC, methanamine, ethanamine, propane 1-amine, like shows that it's in the corner. Butanamine, one just shows that it's in the corner, that way. Pentanamine, hexanamine, octanamine, pretty straightforward. Okay. So secondary and tertiary, you just like mention this thing.
Ma'am, what happens if we like don't put the one?
You need to, because again, like if I just say like methanamine, ethanamine doesn't matter because wherever you put it, it's going to be the same structure. Propan के लिए अगर center में है versus edge में है, there are two different compounds. So you need to indicate कि propanamine में where is that amine group located. So you need to mention the position number. If I just say pentanamine, pentan tells me that it's a 5-carbon this thing. Amine tells me that there is an NH2 group there, but where is the NH group? I have like 5 possibilities. Where do I attach it? So the number 1 tells me that I have to attach it in the corner.
Ma'am, so now if it was in the middle, wouldn't we start numbering it from there? Like 1, 2, 3?
No, so numbering ke liye you need to have like one continuous thing. So I'll go over the positioning and all. Right now, just ensure that you get familiar with these names, because when we start doing the proper nomenclature, then I don't want you guys to be blank. कि अगर NH है तो क्या है वो, like amine है या azo है या like what is it? Okay, so focus on the names and whether they're prefixes or suffixes, like how exactly they're coming. The rest of the how are you forming the names, we'll do it in the next thing, like when we talk about and all. Yeah.
I got disconnected. Like, what is the difference between amino and amine?
Amine is the name of this functional group, and also you use the name amine to represent amines. Amino is just, this is like another common name that amino.
Before this, like, what did you show?
No, I was just discussing, like amines ka nomenclature only. Methanamine, ethanamine. So they were discussing like position numbers, like important hai kya, what happens if we don't write the position numbers and all that. I was just discussing that.
And why are all of these like propyl, butyl? That's just because like it can be propane and all that also, right?
Common name, traditional name.
No, like it can be propane, butane also, right?
Propane represents that 3 carbon hai and only carbon and hydrogen hai.
No, like propane amine, like that.
Oh, the IUPAC name is propanamine without the E, prop and amine.
Then what is propyl then?
So this tells me that propyl group hai attached amine ke saath. So propyl group is C3H7. C3H8 हुआ तो proper propane हो जाता है. So remove one hydrogen and attach an amine group there.
Is it because nitrogen is always forms triple bonds?
Yeah, that is why it is NH2.
Means?
Nitrogen has valency 3, right? So if at all there is nitrogen here, it should compulsorily bond with 3 different things. So here it happened to be 2 hydrogens and 1 alkyl group, like methyl, ethyl, propyl, jo bhi hai.
But then for propanamine, why are we writing the traditional name as propylamine? I didn't understand that.
That's the common name. That's what people have always called it.
So we don't have to learn that, right?
No.
Only you have to see the IU.
I had it. It's still logical. Like, हमेशा common names में alkyl आ जाता है. Like if it's a chloro compound, it's like methyl chloride or propyl chloride. Amine hai to methylamine, propylamine. It's just a common name. And it's very, very logical. I don't know why it's, for you, you're feeling so. It's IUPAC has set certain rules. So uske hisab se, this is how you need to write it. Anything else other than that, it's just people have just, they observed that propyl group hai or amine group hai. So they just called it propylamine that way. That's it. See, the main thing is you need to be able to recognize it. So what I'll say is like, try to observe the logic behind how all these names are coming about. दो कार्बन एटम है तो it's it, and if there's a functional group it's not pura ethane, so you have ethyl. So if I close this, if I just say hexylamine, so you can make sense of it ना. Hex मतलब okay 6 carbon atoms है, hexyl मतलब alkyl chain है 6 carbon atoms के साथ, और amine group भी है attach हो गया उसमें. So like try to find that kind of a logic behind it, you know. It's basically like a code, that sort of a thing. ठीक है, make sense?
Yes.
So IUPAC gives certain rules. Anything other than that, like you can kind of figure it out from the name itself, like kind of like that. So these are all primary amines, which means the amine group is at the corner of the chain. Okay. Then you have secondary tertiary amines, which means the amine group is attached to more number of carbon atoms. So there's an example here you can see. So primary means, like this is the rule for all of organic chemistry. You can note it down somewhere. So jabibi you have a primary thing like primary alcohol, primary amine, primary carbon, it means that it is attached to one carbon atom. Secondary means it is attached to two carbon atoms. And tertiary means it is attached to three carbon atoms. Okay. So you can see that here. Yahan pe primary amine, because the nitrogen here is attached to only one carbon atom. Yahan pe secondary, this is a secondary amine because it is attached to two carbon atoms, and the third valency is fulfilled by hydrogen. This is a tertiary amine because this nitrogen is attached to 1, 2, 3 carbon atoms. Okay. So in the case of primary amine, the IUPAC naming is like, you know, methanamine, ethanamine, propanamine, like that. Secondary tertiary mein, it becomes a little more, you know, like ethyl methylamine, ethyl methyl butylamine, something like that. Actually, you guys clear about the difference between primary, secondary, tertiary?
Ma'am.
Kaveri, your voice broke. I'm not able to hear you. Hello? Wait. Yeah, I think it's getting
Ma'am, it is not for you, it is for everyone.
Oh, okay. No, there's a lot of disturbance on your line, Kaveri. Not able to hear you.
Ma'am, can you hear me now? Hello?
Abhi aaya.
Yeah, like, can you explain the tertiary again?
Simple. It's just based on the number of carbon atoms that it is attached to. So it is not specific to amines only. This primary, secondary, tertiary is applied to any kind of thing. Like for example, if I write something like this, क्योंकि OH this is an alcoholic compound. What type of alcohol is it? Is it a primary alcohol, secondary alcohol, or tertiary alcohol?
Primary.
So when I have OH group, it is simply, like OH can form only one bond. It cannot, like oxygen agar do bond form kiya to wo ether ho jayega na. So then you need to look at ki the carbon that is attached to the OH, how many carbon atoms it is attached to. So on the basis of that, is it primary, secondary, or tertiary? So ye wala carbon, is this carbon primary, secondary, or tertiary? Anyone can answer this, and appreciate.
Tertiary.
This is a tertiary alcohol. Yeah, that's how the difference between primary, secondary, tertiary is made.
So like it depends on the central atom.
So in this case, it is central, but if there happen to be a longer chain, it's not like the center wala atom. Na? It depends on the atom that either the functional group is attached to or the functional group itself. 90% of the cases for alcohol, for the halogen based compounds, like a lot of these other functional groups that can form only one bond, you look at the carbon that the functional group is attached to. Only in the case of amines, you look at the nitrogen atom. So nitrogen atom kitne carbons ko attached hai. So only in the case of
Ma'am,
yeah.
so for this, for us to like identify if it is primary, secondary, or tertiary, it is necessary to be attached to an functional group, right?
Yeah. Even if it is not attached to the functional group, it needs to have some sort of an importance. So even if I had like an alkane,
I'm still confused. I didn't understand like which, like do we take the central atom, like
yeah, that's what. So like in the case of organic chemistry, forget about central atoms, because you have like ranging from short chains, you have long chains, right? When you have multiple centers, the central atom kaun sa hoga? So like get rid of that notion in organic chemistry. What you need to look at is like the point of interest. Like which is the most important carbon where the reaction is going to take place. Okay. So when there is a functional group attached, that's going to be the place of interest, because the functional group is like kind of like a reactive center. So either the functional group itself will take part in the reactions or the carbon attached to it will take part in the reactions. Okay. And when there's no functional group attached, like for example, if this is the kind of molecule we're looking at, then depending on the type of reaction, like for example, if in the reaction this particular carbon happens to be important, then you look at, okay, how many carbon atoms is this attached to? Oh, agar ye, like, okay, I'm gonna place this here. Let's say this is H. Like how many carbon atoms is this attached to? 1, 2, 3. So this is a tertiary carbon. So whatever are the properties of tertiary carbon, then that's going to undergo the reaction. So suppose there's a tertiary carbon here, but let's say there is something like CH2OH here. Now, because there is OH here, then if the reaction happens to be happening at this particular place, then this becomes the point of interest for us. And then we look at, अच्छा, ये वाले carbon पे OH attached है और यहाँ पे reaction हो रहा है. What type of carbon it is? Oh, attached to only one carbon atom. So this is a primary carbon. So every single carbon atom can be classified into either primary, secondary, or tertiary, depending on how many other carbon atoms it is attached to.
But like by default, if we're told, then we consider the one which is attached to the functional group.
Yeah, so that's like the main point of interest. Yeah.
Okay. And then not just like carbon, right? Any, like you gave the example of alcohol. So will it like, do we consider if a functional group is primary, secondary, tertiary, or would it just be for a carbon atom?
Mostly the functional group. Only in the case of amines, because nitrogen is capable of, is forming like 3 different bonds. You have
Yeah.
primary amines, secondary amines, and tertiary amines.
No, like functional, I meant like functional group means in this case you've given the recent one that you just gave it, the primary carbon. So we took we took carbon as the main thing because it is attached to the functional group. So we said it's primary. But then in the alcohol one, what have you done?
Yeah, baby, like again, where the functional group is attached, this is our place of interest, the carbon of interest. And this is
So we would say that OH is the primary this thing, like
no.
because
So this is a tertiary alcohol because the functional group is attached to a tertiary carbon atom. That's what I'm saying. Only in the case of amines, it's kind of like an exception because nitrogen is capable of forming like 3 bonds. All other cases that I can think of, whether it's OH or whether it's Cl or any other functional group, is, whatever carbon is attached to the functional group.
So in the case of amines, like the amine itself, we will consider as primary, secondary, tertiary.
Yes.
But in the other, we will only take it like for the carbon, which is attached to the functional group.
Correct. Yeah. Okay. Yeah. So this is the difference between primary, secondary, tertiary. When it comes to nomenclature, I have an example here. So Iupac name, you have butanamine, then all these are branched stuff. Oh, there you go, secondary. So just like your what do you call, ether का naming जैसा है, the shorter one is considered to be like a substituent. So you have 1-methyl propanamine that way. So यहाँ पे you have a tertiary amine, you have dimethyl ethanamine. So the smaller, like wherever you have smaller carbon atoms, they get turned into alkyl, like methyl, ethyl, propyl, जो भी है. And then the longest chain along with nitrogen is considered for the parent name. Methanamine, propanamine, butanamine, that kind of a thing.
Ma'am, could you go back?
Yeah. It's a little unclear, right? Actually, I'll erase and I'll write it here. So secondary amines के लिए, so alkyl, alkanamine, इसमें alkyl is the shorter one and alkanamine would be the longer one. Same is the case with tertiary amines also. So if you have nitrogen attached to 3 different. So R1.
What is it?
Huh?
What is it? Alkyl? How do you like? What is the whole thing?
So alkyl, alkanamine. So NH2 is also like alkanamine, right? Like methanamine, propanamine, that way. In this case also, it'll be the same alkanamine, but whichever is the shorter alkyl group attached, that is treated as a substituent. It's just called alkyl, like methyl ethanamine. Give an example here. So suppose I have NH, methyl group attached on one side and ethyl group attached on the other side. So the longer, so nitrogen hai, on this side of nitrogen is ethyl, on this side of nitrogen is methyl, like 1 carbon and 2 carbon. So this is longer, right? So your parent name is going to be ethanamine. And यहाँ पे जो shorter carbon है, that becomes methyl. So methyl ethanamine. So even tertiary will follow the same rules. Except instead of a single alkyl, it will be like methyl ethyl propanamine or dimethyl ethanamine, like that. Guys, keep talking, huh? When you're done, like noting down or something.
And
Done, ma'am.
1 second. Have you written an example for tertiary amine?
Not yet. I'll like this is pretty crowded, right? So I'll do it in the next page.
Yeah, okay, I'm done.
So example for tertiary. Let's say you have nitrogen, CH2, CH2, CH3, and यहाँ पे एक CH3 है, यहाँ पे एक CH3. So in this case, which is the longest carbon chain connected to nitrogen?
it could be any chain in that CH3 till CH3.
Longest, Rishit, which has maximum number of carbon atoms?
Propane.
Prop. 3, like call it propyl because this is not independent propane. No? So the propyl group is the longest chain connected. So the root word becomes propanamine. Showing that propanamine, like amine group hai, 3 carbon atom long chain hai. This is propanamine part. And what are the other 2 things we have not considered? So यहाँ पे एक CH3.
Methyl.
Yeah.
2 methyls.
So there's 2 methyls groups. So because there's 2
So it will be
methyl,
dimethyl propanamine.
we can shorten it to dimethyl. It should be one word, like IUPAC names hamesha like write it as one word only. Yeah. So if this happened to be different, agar ek methyl ek ethyl hai, so it will turn into ethyl methyl propanamine that way.
And what was the general formula for tertiary amine?
Just like secondary. Like secondary mein there's only one alkyl alkanamine. Tertiary mein you'll have 2 alkyls.
So like just dialkyl.
Yeah, what groups are there? Yeah, mention all of those groups and longest will have alkanamine.
Mention all of those groups means?
मतलब बाकी जो भी है, अगर एक मिथाइल एक इथाइल है तो इथाइल मिथाइल होगा. एक ब्यूटाइल एक मिथाइल है तो मिथाइल ब्यूटाइल, like that way. दो ethyl है तो diethyl होगा, that way.
Okay, okay. So if and the longest one would be what, and the shortest one would be what?
Longest is alkanamine, AMINE. And other than longest, whatever you've left, just mention them as ethyl, methyl, ethyl, like diethyl, methyl, propyl, whatever, in alphabetical order.
Okay.
Okay. All right. Kaveri, I just saw, so you said you are done? Sanat, Rishit?
Yeah, I'm done too.
Cool. What are the functional groups? Like these are like the main ones that you guys have. Halo group ho gaya, oxygen based groups ho gaye, amine like nitrogen based groups ho gaye. There's a lot more. Oh yeah, a few others. Nitrogen based mein hi. So if you have C triple bond N, also shortened to CN. So this group is called the nitrile group. NITRILE, nitrile group. Also referred to as cyanide group. Yeah. So the name also follows like methane nitrile, ethane nitrile, that way, ends with nitrile. Common name may can, like, people may tend to use cyanide also. Then you have NO2, which is the nitro group. So nitro will be used as a prefix. So nitrobenzene, nitrohexane, paranitrotoluene, like things like that. What other functional groups would you have? Esters, okay. So if you have something of the form R, C double bond O, O, till here it's like acid, but yahan pe instead of hydrogen, if you have another carbon chain. So this group of compounds are called esters, and the name will be alkyl alkanoate. So I'll color code it so you know. Alkyl alkanoate. So whatever is beyond oxygen, yahan pe jo aa raha hai, that's your alkyl, and whatever is attached to the C double bond O, yahan pe jo aa raha hai, that's your alkanoate.
Ma'am, C triple bond N is nitride, right?
Nitrile. So isme, like, it's not important immediately, but eventually you'll come across this grade 12 mein. Now, depending on which side the bond is formed, whether it's on the carbon wala side or the nitrogen wala side, agar carbon se bond form hua, to it's called nitrile. Agar nitrogen se bond form hua, then it's called isonitrile. But that's like a special case. Don't worry about it now. Just mentioning for your information type. when we study about it, we'll talk about it then. But because it's not like brand new, just know that कहीं से भी bond form हो सकता है, either carbon or nitrogen. Depending on where it is formed, it's called nitrile or isomeric.
Ma'am,
Yeah, Sanat?
in esters, the alkyl will be of the shorter chain or the longer
There's no
chain?
shorter, longer. It depends on the placement. So that's why I've color coded it. So I'll write it with that color.
Can you explain it with an example?
Yes. So once you guys are done noting it down, then I'll.
Ma'am,
Yeah, Kaveri.
C triple bond N and C single bond.
C triple bond and like, no, this group as a whole, that's called the nitrile group. Sometimes it's also called cyanide.
No, just CN. Like,
It's like CN ko hi agar bonds, if you're showing it, it's C triple bond N. The same thing. So this
Acha.
is showing the structure and this is what it's shortened to. So if you see C and N together like in this form, basically there's a triple bond between C and N. That's all.
Ma'am, sorry to make you repeat, but could you repeat what exactly were esters?
Ester. Like
Esters,
wrote it
sorry.
down. Sorry, can you repeat that, Rashid?
Yes, ma'am, esters only. Could you
Ester.
like yeah.
Finish noting it down, then I'll talk about it so that you guys can see and like you can focus. Cool. Kaveri is done. Rishabh is done. Okay. Sanat, let me know when you're done and then I'll do stuff.
Just a minute, ma'am. I'm writing the esters ka last part.
ठीक है.
Yeah, okay, I'm done.
Okay. Esters are a special type of compounds. So they're formed from acid. So like acid plus alcohol together, they form esters. Okay. So exactly how it is you have acid. Do you know what is the functional group for acid? You remember that?
Carboxylic acid.
Yes.
COOH.
Yeah. Structure, if I had to expand it, it's C double bond OH. And alcohols are made up of this OH. So what happens is, like, of course, there's reagents and all involved, but we are not doing the reaction. So when acid and alcohol may say, OH from the acid and H from the alcohol, like there is one water molecule lost to give an ester. So यहाँ पे एक bond रह गया और यहाँ पे O और H के बीच में जो bond break हुआ, like there's another bond that is there, right? So these two join in to form an ester. So that's why an ester looks like this. You have a carbon chain, the C double bond O part from the acid, and then the OR dash from the alcohol. So the name, you need to look at what is attached to the C double bond O and what is attached to the oxygen. So here it doesn't matter what is long, what is short. You need to see the structure of C double bond O के साथ क्या है और oxygen के साथ क्या है. Okay, so like just oxygen say whatever is attached, that will become alkyl, and the C double bond O के साथ whatever is attached, that becomes alkanoid. Okay. Now I'll give an example. Let's say we have CH3, C double bond O, O, C3H8. तो इसका नाम क्या होगा? So you need to look at oxygen से what is attached.
Propyl.
Propyl, yes. And when I say what is attached to C double bond O, you also need to count this carbon. So including this, how many carbons long is the C double bond O wala carbon?
How does C3H8 make sense?
Good catch. So it should be C3H7 alkyl. My bad. Huh. Now what should be like? What is the number of carbons attached to the C double bond O part of it, including the C double bond O?
2.
2 मतलब prefix क्या होगा?
Methane, ethyl.
Eth, right? Yeah. So that becomes ethanoate. Ethanoate. Okay. Similarly, if I have, let's say, H, C double bond O, O, CH2, CH3. So you guys try this out. नाम क्या होगा?
In chat.
हाँ, send it in chat. Do this, and after that, do this also. So instead of the structure, I gave it in short form. I wrote CO. Kaveri got the hang of it. This is correct. So you can number it, like let's say this is 2 and this is 3, considering this is 1. Rishad also got it. Good.
Also, ma'am, it won't be C3H7, right? It'll be C3H5, right?
That's 7.
If it's propyl and the formula for AN is CN H2 and H2N plus 2. Sorry.
Ma'am, I'm getting confused in it.
Look at this format. Okay. So corresponding to the green part of it, kya hai idhar? How many carbon atoms are there?
1.
1 मतलब prefix क्या होना चाहिए?
Meth.
Meth. So should I write methyl or should I write methanoate?
Methanoid.
There you go. So how will you account for this? देख यहाँ पे, what should I represent this as?
There are 2. Oh wait, ethyl methanoid.
There you go.
No, I got confused by the COO.
You need to count this one up.
Yeah.
It's the same thing. It's
I
just,
thought like they were the same.
shortened. Rishad, Kaveri, you guys also got it. So Sanat, you also figure this out.
methyl ethanoid.
There you go. So only one carbon atom, there's two over here. So this is methyl ethanoid.
I'm just asking. So, for example, in the alcohol functional group, for R, methyl O, whatever, R, oxygen, and R.
That's
In that also
not
we wrote.
alcohol. These
Sorry?
are called ethers, not alcohol.
They don't come under it.
No, alcohol is OH. These are ethers.
Okay. Basically, their structure would be ROR only, right? If there is something that like that, then it is called ethers, correct?
Correct.
Okay.
Ma'am, could you go to the last slide?
Yeah. So like this is usually done in the presence of H2SO4 that I hadn't mentioned, but yeah, like specifics is not necessary right now because you're just introduced to esters.
Will be asked about ester bonds?
Not right now. You'll study about esters in 12th standard, like acid, yeah, alcohol ke chapter. But in case you're asked about the name, that's how you identify it. C double bond O kahan se aa raha hai, and like this side of it kahan se aa raha hai. That's where the name comes from. Acha, at all three of you using Android, or is any of you using iOS?
Like laptop?
Phones.
Android.
I am on Android.
Android.
I'm on.
And you're on iOS, actually.
Are we talking about Flipper?
No, Flipper, yeah, you guys can do. No, specific to chemistry, there's an app called Chemistry Lab, which takes you through like the whole thing. Periodic ke baare mein hai, inorganic, organic, they're all there. So I found that to be really good with organic, right from the basics, key electrons kaise move karte hain and all of that. So I'll just go through it once again. If there's things that's relevant to you guys, I'll send you the link. I haven't found it on iOS. That's why I wanted to ask you. Like, to Android पे तो definitely है. I couldn't find that app.
What is the app name again?
It's called Chemistry Lab. So this iOS pe I see there's something called Mechanisms Organic Chemistry, but that may or may not be. Anyway, let me just see. And this was something I found like some 3-4 years ago. So I'll just see what updates are there. If it's still relevant, then I'll send it to you guys. Okay, so we're done. So these are like major functional groups. This is what you need to be familiar with. There's more, like you have cyanate, thiocyanate, and SCN and all of that stuff, but not relevant right now. You don't have it in your syllabus. And it's not like completely exhaustive because there's honestly like a ton of functional groups in organic chemistry. Okay, now coming to the rules of naming. So we'll do this in two parts, okay? So first we'll look at only hydrocarbons. Let's get familiar with this. Then we'll add on the functional groups to it. Actually, it's 5:34, right? Should we continue this in the next class?